Welcome to the session on forces and friction, resolving forces. The objectives for this session are to resolve forces into components and use the triangle law to find the resultant force. When a force is applied at an angle to the direction of motion, we can resolve it to find the component of the force acting in the direction of motion. Let's take a look at an example. Suppose that a box is dragged along the floor by a force of magnitude F. The box is moving horizontally, and the angle between the direction of motion and the force is theta, as shown in the diagram. The component of a force of magnitude F in a given direction is F cos theta, where theta is the size of the angle between the direction and the force. So, if we resolve force in direction of motion, we can use the formula cos theta equals adjacent over hypotenuse to give us that mod AB, as shown in the diagram, equals F cos theta. We can apply this to particular examples which are very interesting. So, for example, when F acts in the direction D, as shown in the diagram, then the component of F in that direction is F cos 0 degrees, which equals F times 1, which is F. When F acts at right angles to the direction D, then the component of F in that direction is F cos 90 degrees, which equals F times 0, which is 0. And when F acts in the direction opposite to direction D, as shown in the last diagram, then the component of F in direction D is F cos 180 degrees, which equals F times minus 1, which equals minus F. Now let's take a look at another example. Find the component of the force in the diagram in the x direction and the y direction. Hence write each force in the form Pi plus Qj, where I and j are unit vectors in the x and y directions respectively. Pause the video and have a go. Press play when you're ready to view the solutions. The vertical component, as you can see from the diagram, is equal to 6 sine 30 degrees. And the horizontal component is 6 cos 30 degrees. Therefore, the size of the horizontal component of the force is 6 times root 3 over 2, because the value of cos 30 degrees is root 3 over 2. And the size of the vertical component of the force is 6 times a half, because sine 30 equals a half. And therefore, we have that the component of the force in the x direction is 3 root 3, and the component of the force in the y direction is minus 3. Therefore, F, the force, equals 3 root 3 I minus 3j. Now let's take a look at another example. A brick of mass 2 kilograms lies on a smooth horizontal floor. The brick is pulled by a force of 7 newtons applied at an angle of 60 degrees to the horizontal. This causes the brick to accelerate horizontally along the floor. We are required to find the acceleration of the brick and find the normal reaction of the brick with the floor. Pause the video and have a go. Press play when you're ready to view the solutions. Let's draw a diagram first. Here's our brick, weighing 2 kilograms. We have a reactionary force and we have the weight pulling down on it. We also have a force being pulled or being applied to it at an angle of 60 degrees. So here's our mass of 2 kilograms. Here's our 7 Newton force being applied at an angle of 60 degrees. And here's the weight, 2g newtons. And then if we resolve vertically, of course, using F equals ma, and acceleration being the force of gravity, we have F equals 2g newtons. Let's solve part A first, now that we have our diagram. We are required to find the acceleration of the brick. Resolving horizontally using F equals ma, we have the force horizontally is 7 cos 60 degrees equals 2 times a, the acceleration. And so this gives us 7 times a half equals 2a. Since cos 60 degrees equals a half. And rearranging this gives us a equals 7 over 4. Or 1 3/4. Now for part B. We are required to find the normal reaction of the brick with the floor. So let's resolve vertically. We have R plus 7 sine 60 degrees, that's the force in the vertical direction, equals, and this is the upward direction, in the downward direction we have 2g. So the forces acting upwards equal the forces acting downwards. And in this example, there's only one force acting downwards. So if we substitute now, g equals 9.8 and sine 60 equals root 3 over 2, we have r plus 7 root 3 over 2 equals 2 times 9.8. And solving for r gives us that r equals 13.5 newtons. Now let's take a look at the triangle law of vector addition. This can be used to find the resultant of two forces acting at an angle without resolving them into components. Let's take a look at an example. Suppose two forces act on a particle as shown in this diagram. We are required to work out the magnitude and direction of the resultant force. Notice that 50 degrees plus 25 degrees, as shown, equals 75 degrees. Therefore, if we reconfigure this diagram into a triangle, we can do this as shown. We take the 9 Newton force up, like so, and then join the forces, as shown here, by this line. And this is the resultant force that we're required to find. We're now going to use the cosine rule to calculate R, the resultant force. We have R squared equals 9 squared plus 15 squared minus 9 here times 15 cos 105. And this is where the 15s go, and this is where 105 goes. And plugging these values into your calculator should give you R squared equals 340.94 0.057. And this implies that R equals 18.46458, which is R equals 18.5 to 3 significant figures. We can now use the sine rule to calculate theta. So sine theta divided by 9 equals sine 105 divided by R, which equals, and if we use the original value rather than the rounded value, we'll obtain a more accurate answer. So we're going to use 18.46458. And this gives us sine theta equals 0.47081, which implies that theta equals 28.1 degrees to 3 significant figures. So from the diagram, we have that alpha equals 50 degrees minus 28.1 degrees. Which equals 21.9 degrees. So the resultant force R has a magnitude of 18.5 newtons and acts at an angle of 21.9 degrees above the horizontal. Let's now take a look at another example. 3 forces act upon a particle as shown in the diagram. Calculate the magnitude of P given that the particle is in equilibrium. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. Let's resolve horizontally first, taking the right-hand side as the positive direction. Let's take a look at the 170 Newton force first. Resolving horizontally, we have 170 cos 60 degrees, and then the P force, we have plus P cos theta, and then in the other direction the 130 Newton force. So this is going to equal 130 cos 30 degrees. So tidying up and plugging values into our calculator gives us P cos theta equals 27.58330. Now let's resolve vertically. In the part above the x-axis, we have, with the 170 Newton force, 170 sine 60 degrees, plus, now for the 130 Newton force, 130 sine 30 degrees, and this is going to equal P sine theta, as this part is below the x-axis. And so tidying up and plugging values into our calculator gives us that P sine theta equals 212.22431. So therefore now we have P sine theta over P cos theta equals 7.69394. And of course, P sine theta over P cos theta is tan theta. Therefore, tan theta equals 7.69394. And if we plug this into our calculator, we obtain that theta equals 82.6 degrees. Now from 1, or equation 1, we have p cos theta equals 27.58330. So we can now substitute theta into this equation as shown, to give us P equals 214 newtons. This brings us to the end of this session. If you have understood its contents, you should be able to resolve forces into components and use the triangle law to find the resultant force. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.